Good afternoon, everyone. Today we want to look at measurement and units. We know in our day-to-day activities we take measurements. Even from our kitchen, we take measurements. We measure the food that we want to cook. Do a lot of measurements. Even when we go to the market, we do a lot of measurements. Even our day-to-day walking from one place to another, we make measurements. When you want to cross the road, you check a coming vehicle and you calculate that, oh, you can still cross the road before the vehicle gets close to you. That is measurement on its own. So what is measurement? The measurement assign a numerical value to a physical quantity. And how does it do that? Good. By comparing the unknown quantity with a known quantity. For example, now, if you want to know the length of your notebook, you just place your ruler across it. Your ruler is a what? A known physical quantity, a standard. You put it against your note, and you are able to tell the length of your notebook. That is what we call measurement. Now, let's take a look at several kilometers. This is an example. Several kilometers. Now, the seven there is a numerical value. This numerical value is talking about a physical quantity, which is what? Length. And the unit of the length measured here is kilometer. You can see this is measurement. Someone has measured the length of his journey to the 7 kilometers. You have the numerical value 7. The length of the journey is being measured. That is the quantity that is being measured. The unit of the quantity as used here is kilometer. That is what we refer to as measurement. We'll go through this very fast because most of you have been used to this. I can still go through the PDF at a convenient time. It's very easy to understand so that we can go to more pressing areas. Now, let's take a look at length, area, and volume. The length is the interval between 2 points. What are the measuring tools for length? You want to measure a very small length, like the thickness of a wire or thickness of a needle, you can use micrometer. If you want to measure something that is bigger than that, okay, for example, you want to measure the thickness of your pen, you can use vernier caliper. You want to measure short length, not as short as this one, you can use your ruler, like length of your notebook. You want to measure your eyes, you can use tape. You want to measure the length of a door, you can use tape. When you want to measure long length, you can use trundle wheel. You want to measure the length of a football field now, you can use trundle wheel. If you want to measure a very long distance, you can use odometer. That is the device that is installed in vehicles to measure distance that has been traveling by this vehicle. So the odometer keep on measuring the distance being covered by the vehicle. So let's go to area. What is area? Area is the region of space enclosed by two-dimensional shape. Two-dimensional shape. If I have something like this, the area enclosed by this rectangle is called area. So how do we measure area? How do we measure area? We have area of a regular shape. We already have different formulae for areas of different shapes. But for a regular solid, to measure a regular solid, we need to keep on dividing it until we are able to divide it into different regular shapes. For example, if I want to measure, now, this is not a regular shape. This is not a regular shape. If I want to measure this shape now, I can cut it here. I can now calculate the area of this rectangle, calculate the area of this rectangle, and sum it up. That's how we calculate area of a regular shape. Sometimes you can even convert. Okay, for example, look at this. This is an irregular shape, but you can see the shape. I can divide it the way I like it. I can divide it the way there's a triangle here, there's a triangle here. I can measure this triangle here, I measure this triangle here. That's how to measure area of a regular shape. So let's proceed. Now, how do we measure volume? Volume is the space enclosed by a solid, that is a three-dimensional shape. Volume of a regular solid are calculated with formulae that are already established. For example, volume of a cuboid is calculated using length times breadth times height. Volume of a cylinder is calculated using pi r square h. So for all regular solids, we already have formulae for calculating them. But what happens if you want to calculate volume of an irregular solid, e.g. a stone? How do you do it? We can make use of what we call displacement can. How does displacement can, how does it work? You have a can like this that has something like a funnel here. It has an opening there. So we put a liquid to the brim here, make sure that the liquid is almost dropping from the opening. Then we drop a solid into this place. So the liquid that gets out of this place will be taken into a container and can be what? Measured. The volume of the liquid that is displaced will be the volume of the what? Solid that will be measured. If you don't want to use displacement can, you can also use graduated cylinder for that. The graduated cylinder is already calibrated like this, already calibrated. We have 1 cm cube, 2 cm cube, 3 cm cube. So if you have if you have a liquid at 1 cm cube, and this is 1 cm cube, and you now drop a solid into it, and the level of the liquid now rises to level 3, 3 cm cube. So that means the volume of the solid is 2 cm cube, 3 minus 1. So that's how we make use of graduated cylinder to do that. So but if you want to measure the volume of liquid, you can use graduated cylinder also. By pouring the liquid in it, we're going to measure it. You can use volumetric flask. You can use for little amount of liquid. You can use burette and pipette. So let's look at mass. What is mass? Mass is the quantity of matter in a body. The quantity of matter in your body is your mass. So the instrument that we normally use to measure this is the beam balance. And this beam balance works on the principle of balance, principle of moment, where principle of equilibrium of masses, where a mass is balanced against another one. You have a known mass and you balance it against what? An unknown mass. And when you're able to do that, you're able to calculate the mass of the what? Of the solid. Sometimes some students normally make the mistake of saying that we use spring balance to measure mass. Yes, they are partly right. You can use spring balance to measure mass of a body, but you cannot use it to measure it directly. You can use spring balance to measure weight of a body, and from the weight you can get the mass. If you know the acceleration due to gravity at the region where you are doing the measurement. For example, now if you measure the mass of an object using spring balance at one location, if you go to another location and measure the same mass, you are going to get different results because of the acceleration due to gravity varies sparingly. It varies on the surface of the world of the earth. So to measure the mass of chemical, we make use of what we call chemical balance. You can always read this off. They are just reading stuff. Now let's go to time. Time is the interval between two related events. And during the days of the old, they normally use hourglass that makes use of two regions of glasses and sand. Sand will be pouring from one glass to the another. The time it takes the sand to pour from one bulb to the other is an hour. And you can use it to measure the length of time. So sundial, that one makes use of shadow. So, but we are very lucky in our own time. We have sophisticated time measuring devices like stopwatch, digital clock, light gauge. So they are very efficient in measuring time. So let's go to fundamental and derived quantities. Fundamental quantities are the quantities that cannot be reduced to simpler quantities because they are the basic quantities. They are the basic. They are not formed from any other quantity. They are the basic. So examples All the fundamental quantity has been abbreviated into the acronym METAL. I could have said word, but it's acronym because metal has a single T and a single L. But in this, we have double T and double L. So the mass, the M, the stand for the mass, which is measured in kilogram. The ED stand for electric current, which is measured in ampere. And we have T, which is time, measured in seconds. We have thermodynamic temperature, which is measured in Kelvin. We have the A standing for amount of substance, which is measured in mole. And we have length, which is measured in meter. And we have luminous intensity, which is measured in candela. Please take note of what they are measured in and their units, how they are written, the abbreviation for the unit. Take note of that, very, very important. So we now have what we call supplementary units. You see, all these fundamental units, they have all the fundamental units, they have dimensions. But you see, these supplementary units, these supplementary quantities, they do not have dimensions. They are dimensionless. You see later know what I mean by they are dimensionless. They are just measuring angle. One is measuring angle of a circle, and the other one is measuring angle in a what? In a sphere. The other one is plane angle is measuring angle in a circle, while solid angle is measuring angle in a what? In a sphere. So we're not going to spend so much time there. So let's go to dimension. This is very, very important. Take note. The power to which the fundamental units are raised to result into a physical quantity, revealing its nature without giving its magnitude, is called dimension. What do I mean by this? What I mean is this. If I have M, L, T now, if I have M, L, T, if I give this one 0, I just try to give them value as I want. I give this one 0. If I give this one -3, and I give this one 1, this is going to be density. How? Because mass, this capital M is for mass. Mass is measured in kilograms. And this is L raised to power 3. L raised to power 3 is volume. So, but because of the negative, the volume is going to be under kilogram, meter, L is meter cube. And kilogram per meter cube, this is density. You see, if I change the value on this thing again, on this dimension, and I put some set of values, I might land on another word, quantity. But we don't do it that way. We actually calculate it from the what? A particular quantity, then we get its dimension. Because it is possible to put a value on this dimension and it does not give us any known physical quantity. So that's why we don't do it that way. So yeah, let's see what I can do. Okay, let me clear hold. Okay. Now let's look at the dimension. Let's look at the dimension of density. This is mass. Mass is capital M. Length is capital L. And time is capital T. Those are the basic ones. Capital M, capital L, capital T. Now, look at volume. Volume is length times breadth. Breadth is also length times, because we are all measuring length of something. So, length, even height is also what? Length. So, this is mass over length raised to power 3. So, we now write it this way. M raised to power 1. L raised, when we bring the L up, according to law of indices, when we bring the L up, because L raised to power -3, then T. And that there's no T there, we say T raised to power of what? 0. So this is the dimension of density. So we are going to continue from here in our next video. Thank you.